4. I can put right here. Take out GCF. Always do the GCF first. Find the combination. Combination is when there are 3 terms. Okay. And the highest power is 2. The x squared something. Grouping. How do you know when you do grouping? 4 terms. Formula. How do you know when you do formula? It's 2 terms. Yeah. Also 2 terms. Only 2 terms. Then this is the last technique that we're going to learn today. Rational root theorem. When we're going to use this, it's not fancy, right? It's not fancy. When we're going to know, when do we know we're going to use this? Let balance it here. When there's more than 4 terms, like 5 terms, 6 terms, then you use this. Or when none of this works, then you use this. Okay? That's what we're going to learn today. Rational root theorem. It's gonna be fine. It's not the same Daisy anymore. No, stop saying that to yourself. Actually, you got a lot. You got a lot. Yeah. So not the same person anymore. All right. Can we start? We have a short day today, so let's get started. I don't want to like make it like 2 lessons because it's not that hard. It's just the heaviest one because you need to guessing the solution. You will see why. It's just guessing. Guessing part is the hardest one. How do we handle this? What technique we're gonna use? Is it any GCF? No. So hardy combination. Yeah. Hardy combination, 3 terms, and the square. What are 2 numbers multiplied to 4? 1 and 4. And 2 and 2. Which one do you think you can get 4? 1 and 4. Good way to start a lesson. Heart attack. Which one gives you 4? 2 and 2. All right. What is the sign of 2 that can give you 4? What is the sign of this 2? So I can give you 4. Positive 4. Positive and negative. Positive. Right. Now what is solution? X is -2. I have another x equal to -2. Right. So this is dr. Yeah, so this is just review. We're still reviewing. I want to refresh your mind before we move into the last technique of factoring. 4 terms. What technique we're going to use? Grouping. Good. Grouping the first 2. What is the GCF for the first 2? X squared. All right. X cubed, you took out x squared. What do you have left? X. Plus 1. Very good. Plus 1. X squared. I took out x squared. I have 1. What is GCF for the last 2? What should I take out? -4x and -4. What do you take out? -4. There's no x over here. No, I'm sorry. How to say x? My ear is very good because I play music, so my ear very good. I can hear everything. Okay, -4x. You took out -4. What do you have left? That means you divided. In case you don't know, you divided. So you have left x, right? That's right. -4. You took out -4. What do you have left? 1, because you divided. Very good. Positive 1. Now I have a common factor, which is x plus 1. Again, this is just refresh your mind. We already learned this. I just review this. Grouping. Right? And then you have x squared, x plus 1. Okay, in case you don't know, I just write here. I have x squared, x plus 1. And then I took out x plus 1. That means I divided. Okay, that means I divided. Cancel this out, I have left x squared. So I have left x squared inside here. Same thing for this. Okay. -4. Yes, it is -4. And then now this is two term. What technique you gonna use? Yeah, this is the formula, difference of square. Two terms. Right, two terms. So x and x, what square become 4? 2. 1 plus 1 minus. That's the difference of square, the formula. Okay. Now from here you can tell the solution, right? What is the solution? X is plus minus. Very good. X is plus minus 2. X plus 2 and x is -2. So yeah, we combine x is equal to plus minus 2. This is just review. I hope you still remember this. Yes? Yeah? Good, right? Okay. Today, we're going to handle something like this. All right. What is the sign that we need to know that I'm going to use? Right, pi term, right? This is pi term. So that I know that I need to use the rational root theorem because none of the technique going to work. No GCF, it's not 3 terms, so no combinations. It's 5 terms, not 4 terms, so no grouping. And then this is 5 terms, it's not 2 terms, it's not formula. So I'm going to use rational root theorem. Okay. So watch this. Here is the rational root theorem. The last technique for factoring. After this, you're done. No more factoring. You learn every factoring. You already learned all the technique for factoring. Okay. I wrote the step by step right here. I'll leave you the time to write down. I figure out. I think you like step by step, right? Does it help for step by step? So yeah, I start doing that like A, B, C, and then for the 7D, I'm gonna erase this one for 7D. Anyway, you wanna do this. List all the factors of the constants. What is the constant? What is the constant? Who remember? -2. Constant is what?
Oh, the number.
Yes, constant is a number without any letter, without variable. Constant by itself. Okay? Constant is a number by itself. So what is constant here? -2. So you list all the number, all the factor of constant. Let me write small so we can have more space. So list I think we write it the same. I think we write it so I have more space with here. Okay, the constant is -2. The 2. What is the factors of 2? 2 and 1, right? So 1 and 2 are right in order. Also, do you think 2 can divide by -1? Yes, right? And then 2 can 2 divided by -2? Yeah. So actually there's 4 plus -1 plus -2. Okay. Are we good? Stay with me, right? Okay, nothing fancy. Next, you're gonna list all the factors of the leading coefficient. Okay, like the back and the front. So list all the factors of the LC, the leading coefficient. Okay, what is the leading coefficient over here? 1. There's no number. That means they're invisible 1. Okay. What are the factors of 1? 1. 1 and 1 and 1. 1 and 1 and what? 1 and -1. Wow. Plus minus 1. Okay. And here we go. The ratio, yes. Well, plus and minus because this is also the factor of the number. Like let's say 2. 2 can also divide by -1. And 2 also can divide by -2. We list all the factors. So we also list all the negative number. 2 divided by negative 2, 2 divided by negative 1 as well, right? So that total 4. And here, the leading coefficient is 1. 1 can divide by 1, and 1 can divide by negative 1. So that's why you have positive, negative, yeah.
Wait, so we only put one just because it was X, like X.
Because the number is 1, the leading coefficient is 1. Yeah. Like if let's say if the leading coefficient is odd number like 5, then it's going to be 1 and 5. Plus minus 1 plus minus 5.
No, I mean, but by leading coefficient, you don't have this one.
Right. Leading coefficient is the coefficient of the highest power. And the coefficient is the number, only the number. Diego, did I answer your question? Yeah. You don't know why this is negative? Negative because, okay, we list all the factor of 1. That means all the number that 1 can be divided by. So can 1 divided by 1? Yes. Can 1 divided by negative 1? Yes, right? 1 divided by negative 1 is negative 1, right? So you list all the factor that 1 can be divided by. So the rational root theorem is saying that this is very powerful. The rational root theorem is saying that all the solution for this polynomial is when you divide this to this. I'm going to say it again. Yes. Here, leading coefficient is the one with the highest power. Huh? No. This is the definition we learned last time. Leading coefficient is the coefficient of the one with the highest power.
But she said why is it plus and negative?
Oh, we have same question with Diego because I list all the factor of 1. That means I find all the number that 1 can divide by, right? So it can 1 divided by 1? Can 1 divided by negative 1? No. You just find any factor that 1 can be divided by, no matter what is the sign is. So you need to include the positive and negative. Okay. All right. Let me say again the rational theorem. Rational root theorem saying that all the solution for this polynomial is when you divide this by this.
So how would you divide?
Here. Like 1 divided by 1, 2 divided by 1, something like that. They call this is P. They call this is Q. I don't know why. It's just so random. This does not stand for anything. They just call this for fun. Maybe because they opposites. So when they call P and Q, they're saying that all the solution for this polynomial is P divided by Q. So that's why they also call P over Q method. P over Q method. So all possible solution of what? You're going to divide this one by this, everything, okay? So I have 1 divided by 1. What is 1 divided by 1? 1. So plus minus 1. And then next one, 2 divided by 1. What is 2 divided by 1? 2. So plus minus 2. So these are the candidates for the solution. How many candidates I have? This is the candidate for the solution. I call candidate, like
Candidate.
candidate. Candidates? Candidates?
Yeah, candidate.
Candidates.
Yeah,
Candidate. Thank you. Candidates. This is a candidate. Oh, got it. Okay. Close. Okay. This is a candidates. Oh, I like the word candidate. This is a candidates for the solution. Okay. How many candidates I have? Not 2. 4. Yeah. Plus positive 1 and negative 1. Positive 2 and negative 2. Right? I have 4. But I don't know which one is solution. They are just candidates. I don't know which one. So how do I know which one is solution? I'm gonna use synthetic division to check it. Okay. I use synthetic division to check it. All right, use synthetic division. Okay, which one you want to try first? 1, -1, 2, -2. Which one you want to try first? A number, but between these four. 1, okay, let's try 1. I hope you still remember how to do synthetic division, but if not, we can just do together here to review it. I'm gonna put 1 outside like this because that's what I want to check. And then I put it here is 1 because it is the coefficient of the highest power. I'm going down. -1. I go down 3, I go down 2. Oh, I have 2, so -1. 2 go down to 1 again here, -1, and then -2. Why didn't I fill in any 0? Why don't I need any 0? Because I have all the power. Yes, because I have all the power. From 4, 3, 2, 1, and constant. If I'm missing any power, I need to fill in the 0. Okay, I'm reviewing the synthetic division right here. And then, what is the first step for synthetic division? Bring down the 1, very good. And then multiply, add, right? In case you forgot, I just put it here, multiply. You know which one, what we're gonna do. Multiply here. 1 times 1 is 1. And then you add them. Okay, you add 0. Don't be freaked out when you see 0, to keep going. 0 times 1 is 0. And then add -1 plus 0 is -1. Multiply. What do you have? Add them. What do you have? -2. Multiply. What do you have? -2. Add them. What do you have? -4. Okay. How do you know if 1 is a solution or not? What do you think?
You would get. Oh wait, no, you have to go in backwards.
No, I mean, how do I know if 1 is a solution or not? It will based on the remainder. So when do I know 1 is a solution?
Have the remainder of -2.
No.
No.
How do I know 1 is solution?
There's no accident.
Based on the remainder. But what happens to the remainder when it's solution?
It's 0.
0. Very good. When the remainder is 0, then this is the solution.
Can we write that?
But if it's not 0, then this is not solution. Yeah?
Wait, that's.
Yeah, that's why we need to use the synthetic division to check.
What is it?
I want to write here. So this is fail. Because the remainder is not 0. Only when the remainder is 0, then it is a solution. So 1 is not solution. We need to move on to the next candidates. What next number you want to try? 2, okay. So here's the trick. Sometimes I like to alternate the sign, like positive and then negative, positive, negative. A small chance. I figure out this is small chance. I got it. I got the right one. Want to try 2?
We do -2.
Oh yeah, okay. Let's try -2. Okay. So 1, -1, -1, -1, -2. Yes.
So it has to, how would we choose which?
Oh, it's just lucky. It's just random.
5?
So total, how many number you need to check? 4. You just randomly what number you want to check? Oh, 1, -1, 2, and -2. There are 4. Right? And what? So they say that this 4, you need to check all 4. But when you found one solution, then you don't need to check anymore.
So the reason why I said -2 is because it was the only constant. So with a constant, when the one that you use,
No, it's just no. The -2 come from because this is a factor of a constant.
Yeah,
Yes.
that's why.
Yeah,
that's
you
why
will
I-
see that.
That's why I said that though, so I was like, would the constant in the equation?
That's
be-
very good observation. Because also the leading coefficient is 1. That's mean when 2 divided by 1 is 2. But let's say if this is 2, then 2 divided by 2, you have 1. You don't have 2. So also depend on the leading coefficient as well. Yeah. Yeah. I don't know. It's you. Okay. Huh? Yeah. Okay. Go back to here. Let's go back to here. So I'm going to use synthetic division to check if -2 is the solution. Okay. Multiply. Then 2. Add them. Multiply. Add them. 5. Multiply. Add them. Multiply. At this step, I can like kind of see this is not already, right? They're not going to give me 0. So I don't need to calculate this. I don't need to calculate this. I just know this is not 0. So this is not 0. Fail. Okay, what the other number you want to try? +2? Okay, yeah, let's try +2. That's why it says this is kind of obvious because you need to guess. That's the only thing you need to guess. It isn't too bad, right? It isn't too bad. So that you know this unit 7 is easy. No, not always, not always. Okay, let's try this. Chop down to 1. Multiply. Add them. Multiply. Add them. Multiply. Add them. Last one, multiply. Oh, we got this. This is the one. This is the one. Right, there we go. 3 try. 3 try. 3 tries. Okay. Do you remember how to fill in the answer here? Yeah? This is the remainder. This is the constant. This is x. X squared. Good. All right. Now here we go. We're gonna write this. Oh, if you know that 1 is the solution, how can you write in the factor like this? Plus or minus?
And then the other one.
You know 1 is the solution. Then how can you write this? Okay, let's see here. If you have x plus 1, x minus 1, x minus 2, right? Let's say if you have this. What is the solution for the first one? X equal to minus 1. What did you just do? You took the opposite, right? Right? So now you know 1 is a solution. What is the sign for this? Minus. Does it make sense?
Wait, why is one is?
Yeah. I'm saying it again. If you have the factor like this, you're gonna find a solution. How you find it? You take the opposite, right? This is -1, then this is 1.
This isn't the solution.
No, this is just a sample. A sample. I sample. I tell you. If this is -2, then the solution is 2, right? For example. Yeah, you always switches. But now here, you know this is 1 is solution. Then how can you write it? You also need to take the opposite.
Wait, but isn't
But one is not the
the
solution.
Huh?
Isn't two the solution?
Yeah, two is the solution.
No.
But that one doesn't have.
I'm wrong. Yes. I'm just trying to give you the sample. I just saying if 1 is solution. Yeah. So if 2 is solution, then what? -2. Good. Very good.
If it was to be -2, that would be positive.
Yes, if it's in, let's say if this is the solution, then it's going to be +2. Yeah. And then this one is where you fill in this answer from synthetic. Okay. So you have x cubed plus x squared plus x plus 1. Yes? Are you with me on this step? Yes? From here. So here, 2, because 2, I have the remainder 0. So I know 2 is solution. Maybe you can write here, solution, because the remainder is 0. Remainder is 0. Okay, so I know 2 is solution. Then if 2 is solution, when I write, I'm going to write x minus 2. Because we always take the opposite for the solution. Yeah. And then the next parenthesis is the one that we figure out from the synthetic. So just put everything here. Let me just erase some so you can see it right there. I'm going to erase this. Okay. Let me write right here. X minus 2 and then x cubed plus x squared plus x plus 1. Okay. All right. Are you with me in here now? I will leave this. Okay. You still need to break down all the way to know the solution. Okay. You still need to break down everything all the way to find the solution. What technique I'm going to use for this second parenthesis? Huh? Oh, of course, because you cannot tell what is solution for this. You can tell the solution for this, right? But you cannot tell the solution for this. So you need to break it more. What technique you're going to use for this?
Oh, the cube.
The
Never mind.
grouping. Because 4 terms. Okay. Get it. Give it low. What is the GCF for the first 2 terms? X squared. Yeah, I'm waiting for that. X squared. What do we have left when you take out the x squared? X plus 1. And then I have x plus 1 here from here. So this x plus 1 is from here. And then x plus 1 is from this 2. Now I have a common factor x plus 1. I took out the x plus 1. What do I have left? X squared, x plus 1. I took out x plus 1. What do I have left? X squared, right? X plus 1. I took out x plus 1. What do I have left? 1. That's why you need to pay attention. Here. Are we good from here? I'm doing grouping. I'm doing grouping for this. The GCF for the first 2 terms is x squared. I took out the x squared. I have left x plus 1. And then I still have the x plus 1 over here. So x plus 1 is a common factor. I took out the x plus 1 out. Okay. Now x plus x squared, x plus 1. I took out x plus 1. That's me divided. So cancel it. I have left x squared.
For the last parenthesis, where did you get the plus 1?
So here x plus 1. I took out x plus 1. That way I have left 1. X plus 1.
So the one is outside.
Here. Is it a 1 outside over here? It's invisible 1. You have x plus 1, right? And then you took out the x plus 1. What do you have left? You divide them. They're 1. Yeah.
Oh yeah, because it's like that is equal to
Right.
Okay.
But nothing. So that means invisible 1. So from here you can tell the solution already, right? What is this?
X equals
Positive 2. Yeah, take the opposite. What is this?
X equals
Negative 1. How about this? How about this?
0.
X squared plus 1, you let them equal to 0, and you solve this. You remember how to solve this? Okay, isolate it. So x squared equal to negative 1, right? You minus 1 both sides. And then what?
Square. Yeah.
Square root.
X.
You always come back. Yes, I like it. You always come back to the origin. That's why I said don't leave the gap. You always need to come back. Do you remember what is the square root of negative 1? Huh? Imaginary friend. Yes, some of you still remember that.
For the homework.
How many questions?
What is that? What is Huh? What? Huh? Here the thing. Let me finish this. Here the thing.
What is the thing?
You're gonna show us the fourth, right?
Yeah, something like that. Now he knows. Here, it's not a shortcut, but I will just ask you to find all the rational root. Zero. Zero is the same. Zero solution. Find the all rational root. Zero. Okay. That means if you forgot about this, it is still okay. I'm not gonna take point off because imaginary number is not a rational. So as long as you give me this 2, -1, you got a full point. This one I just want to refresh your mind that you still always need to come back. And like how Natalie said, you will always come back to what we have learned. Which one? You said the square root of -1 is I. And then
That's what.
-1 and 2.
That's not good. That's not bad. Algebra.
Yeah. All right. Any question? Any question? Are we good? No question? All right.
Is that all? Or here's the question.
You wish?
I heard of it. This is the best project mine. That's why I put tape on it.
It's a shortcut.
If we do all the way, maybe I can skip some example. If you want to take a break, I will just still keep the same number of example. What do you want?
He just said we didn't solve it all. He said we didn't solve it.
And let's do 2 example. Maybe at least 2 example. Okay. How about this? I give you 5 minutes to write this one down.
I need like.
Oh, you just 2 minutes?
No.
Like 10?
Look, I already had 10.
5 minutes for like this. It's just only 5 lines. Look at this. When you write down on your paper, 1 line, 2 lines, 3 lines, 4 lines. Yeah, you can do it home too.
Bro, Randy, is that on?
So this is
Oh. You're like.
7C. No, it's just born. All right, so write out the note, the middle column, 7C lesson.
No dredge dry, like the desert, like.
Step by step, you practice the rest.
I used to do this when I was younger. I would like stress stick. I'm trying so hard to do it.
Oh, yeah.
It's only one part too. There's so much.
What's that? Yeah. Today is 7C, yes.
Bro, because you were telling us about it.
That's there. I like how it's like good. Very little. Have you guys? I
don't know. I'm sorry.
at this point.
Okay, we done?
Whenever you open.
Use the sound.
If I run, what? Like,
You're outside.
well, I was like, are you not? You like you better than Chad, you know? I'm gonna get
The bar.
Okay, 2 more minutes.
what?
Focus right now. How are you? You have short day today, so let's hurry up. Huh? What?
What's the name? I think it's so oh, I can't get it. You see? I just do red. Because I was like. I just literal go there.
Right, you done?
No.
All right, you done?
No. Oh. Like, I didn't even hear anything. I know. Like, and then my chin too. Ow.
Huh?
Where did you go?
Yeah, class.
Like,
Yeah, class. Oh, good one. You like classes?
oh, plan, it's like, what do you do after school or something?
Oh,
Yeah, that's pretty beautiful.
No idea.
flower?
And apparently he's a study.
Yeah.
He did not know how to see.
Maybe go out.
Why did he even?
Yeah, maybe go, but I don't think it's good time to go out to eat. Okay, very crowded. Yeah.
Maybe tomorrow or Saturday or Sunday.
Yeah, either tomorrow.
Oh, no, give back the choice.
Okay, 1 more minute.
No, Mario needs a bag. We got it first. Sorry.
Oh.
It's gonna be more I just.
All right, we done? Okay. Where were we? See, now I lost. Okay, second assemble. Second assemble. First, this is 4 terms, right? So what technique we're gonna deal with 4 terms? Grouping. But when you try the grouping, it's not working. So that's how you know you're gonna use the rational root theorem. Like, that's why I put it right here. You don't need to write down, but this is the sign. The example 1, we have 5 terms. There are more than 4 terms. Yes, then you're gonna use them.
No.
And then this one, because the grouping doesn't work. When none of the techniques we learn, none of them works, then you're gonna use the rational theorem. Okay. All right. All the factor of the constant. What are they? What is the constant?
3 and 5.
15. All right. So what are the factor of constant? Let's start from small number. So 1, right? Always they always have 1. Plus minus 1. What else? Plus minus 3. What else? Plus minus 5. and 15. Very good. Plus minus 15. Okay. All right, leading coefficient. What is the leading coefficient here? 1. All right. So what is the factor of 1?
Plus minus.
Yeah, plus minus 1. Now you know. Now you know. This is a Q. Okay. So all the possible solution are what? What number? 1 divided by 1, 3 divided by 1. So basically when you see the bottom is 1, I think that's just the whole thing right here, right? Because it's just divided by 1. So basically when you see the bottom is 1, it's all of that. Yes, it's all of this. So plus minus 1, plus minus 3, plus minus 5, plus minus 15. Yeah? P over Q, divide this one by the Q. So 1 divided by 1, I have 1. 3 divided by 1 is 3. 5 divided by 1 is 5. 15 divided by 1 is 15. Basically, when the bottom number is 1, you just copy everything here. Copy everything here. So how many candidates we have? Now I have a pause between the candidates. How many candidates? Remind me to think. How many? 8. Because plus and minus. Don't forget that. 8. What number you want to try? 3? Okay, let's try 3. All right. Now, what number I want to put it right here for the synthetic? 1, negative 3, negative 13, 15. I don't need to fill in any 0 because all the power is here. It's cube, square, 1, and constant. So I don't need to fill in any 0. Okay. Drop down to 1. Multiply. 3. Add them. 0. Multiply. 0. Add them. Negative 13. Multiply. Negative 39. Well, I don't need to calculate this. I know this is not 0, right? So this is no, this is not the one. What else? What else want to check? 5. Okay, let's try 5. 5, okay. 1, negative 3, negative 13, 15. Drop down to 1. Multiply. Add. Multiply. Add. Multiply. Oh, look at this. Add them. You found this. 0. Good. So you found this after 2 tries. About like 8 candidates. That's good. Good art. All right.
This is a shortcut to 5.
No, there's no shortcut. Yeah, there's no shortcut. Yeah. Well, here's the thing, but
No.
if I give you the test, I will not give you like 20 or 30. I give you maybe like just 4 or 6 for you to check. But the chance is you get it like by 3 times or 4 times. Not that bad. Okay. Okay, let's fill in this. This is a constant, right? What is this? X and the square. All right, there we go. We're gonna rewrite this. So I know 5 is a solution. How can I write this?
X equals negative 5. Wait, what? X minus.
It's minus, not equal. Equal the
Oh,
solution.
2, yeah.
Yeah, x minus 5. And then you copy this for the synthetic for the last parenthesis. So x squared plus 2x minus 3. Now, do you think so? This is what technique we're gonna use. What technique we're gonna use? We have 3 terms and you have a square. Combination. What are 2 numbers multiplied to 3? 1 and 3. Do you think 1 and 3 can give you 2? Yes. X minus 5. So x, 1 and 3. What is the sign of 1 and the sign of 3 that can give you positive 2?
1.
What is the sign for 1? Minus and plus. Very good. Minus 1 plus 3 gonna give you positive 2. Now the easy part. What is the solution? X equal to x equal to x equal to. Very good. That's it. So among 5 techniques, which one is your favorite? What do you think? Which one is like easier? Which one is you like? Ripping? Ripping is kind of challenging too.
Is it, Mr. We should have done one with like.
I think that the combination it is kind of simple. Rational root is just like fancy.
Mister, would you put one with cube?
Huh?
Would you put some with cube?
The cube?
Yeah.
You mean the power? Well, yeah, maybe. Maybe. I don't know. I haven't like it yet. Oh, you haven't quiz too.
Did
For a unit 7.
it?
After 70. After this. After 70. Next week, I think. Next week. Huh? Say A, B, C, D. That's it. A, B, C, D. Describe it. I've got everything here. A is about the end behavior. B is about catching. C and D is similar. D is just another lesson of C. So you have free lesson. You don't like 7? 7 easier than 6. Oh, 7B, the roughing? It's sketching. It's not really roughing. It's just sketching. Alright, can I erase this? Yeah?
No.
I snorkel as the blues. Like I realized I was like I thought it's like I just back to text it's spoken.
I really like my own. But this is
That's why I like it not small.
and I was like the mini one here, whatever.
It's crazy.
And it's so. I like that. The back is good. Oh, fine.
Okay. Example number 3. What is the constant? What is the constant? 0? Well, with the 0, this doesn't help you anything. Because if you want to find what is the factor of 0, still 0. It doesn't help. It doesn't help. So, what we're going to do with this problem? Factor what? You need to factor the GCF. I put this one as in order as well. You always need to do this one first in order. Take out a GCF. What is the GCF for this? When you don't have constant, that means you can take out the x. Because no constant, that means every term have at least one x, right? So you need to take out the GCF, which is x. What do we have left? X cubed minus 20x minus. Now you see what is the constant?
Oh, then you have.
Yeah, 48. Now the constant appear. 48. Good.
Oh.
Yeah. Well, yeah, the negative, but it doesn't make. This doesn't matter.
You wouldn't do more after that, like you wouldn't take off.
What do you mean?
Like there's no complication.
Oh, remember, combination is when only when this is square. Yeah. Maybe you can update that right now. Combination is 3 terms with the square. Yes. Yeah, you need to keep it x outside until the end. Yeah, until the end. But for now, you don't need to worry about this. You don't need to worry about this. But at the end, when you write out the answer, you need to have the x because x equal to 0, right? All right, now you know the constant is 48. What are the factors for 48? Oh, good luck.
24.
Let's say go from the smaller number.
24.
1. How about 2? Right? 2. What else? 3. 4 plus 8 is 12. 12 can divide by 3. Do you remember that trick? To see if a number can divide by 3 is to add the digit, the sum. I did say that. I say in every class.
This is a lot of tricks.
How do I know 48 can divide by 3? I get 4 plus 8. I get the sum of all the digits. 4 plus 8 is 12. 12 can divide by 8. 12 can divide by 3. So 48 can divide by 3.
Oh, the sum of the two numbers? If it's divided,
Yeah. Anyway, you have calculator. You can just 48 divided by 3. You just, okay. The shortcut is calculator. Can 48 divided by 4? Yes. You can use the calculator.
Oh my god, this is a lot.
5, no, 6, right? 6. I know there's a lot. 6, 8. What else? 12. 48 divided by 3, 16, right? 48 divided by 3 is 16. If you want to figure out this number, you're going to divide by the small number. 48, like 48 divided by 6, we have 8. 48 divided by 4, 48 divided by 3 is 16. 48 divided by 2 is 24. 48 divided by 4 is 12. Yes, I think that's it. So 48. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. Good luck. What is the factor of leading coefficient? LC. 1. Oh, so basically everything here. When the bottom is 1, so everything here. Okay, everything is the candidates.
I'm gonna just draw an arrow on it.
Which one you want to try first? Which one you want to try? 4? Okay, you want to try 4? Let's try 4.
Wait, would it be positive for you?
Huh?
Would it be positive for you?
Positive what?
Positive 48?
Positive 48?
Yeah.
No, why?
No, I'm just asking you if you could try that.
You want to try for positive 48? Oh, you want to try the solution for positive 48? Not really about the constant. I'm not gonna. I don't think you can try, but I don't think the solution.
I'll ask.
I don't think so. Yeah.
No.
Because you know why? 48, when you put the constant right here, when you multiply to 48, the number really big. The number really big, and it's not gonna give you 0. I think. Yes. Huh? This one? What? This is all the candidates. So you want to try the 4? Okay, let's try 4. What number I'm gonna put it here? 1, negative 28. Right, 0. It's missing. What power are they missing?
Oh, 2.
Oh, 3.
2.
No.
They just say 2, and then you're like 3. Oh, you're looking at this one. Yeah, I'm looking at this one. We start looking at this one.
Right.
So the highest power is 3. I'm looking for the next one is 2, but I don't have any 2 right here. That means I need to put 0. Don't forget this. If you make a mistake on this one, I think mostly will come from the synthetic. Okay. Next one, 28, negative 28. Next one, negative 48. All right. Drop it down. Multiply. Add them. Multiply. Add them. 21, 12. Negative 12. Oh, I think this one worked. Who said 4? Wow, on the first try. Very good. Oh, no, what? Never mind. I'm too excited, too early. It's not.
Yes.
Because I saw 48. But it's not.
After 48.
I saw 48, but it's different size. So close.
Oh, negative 4?
No, it's negative. Something else. Yeah, something
That's
else.
what I said.
Too early.
No.
Oh, positive. I mean,
Negative 4, yeah, that's what I'm talking about. Negative
Huh?
4. Try
Try negative
four, man.
4?
Trying.
Right, so 1 multiply negative 4, add them, negative 4 multiply
It's the same thing.
16, negative 6.
Yeah, it's the same thing. Isn't it?
It's going to be the
No,
same
it's not.
thing. It's going to be the same thing. Yeah.
And he said -4.
Yeah. What else? What else?
Negative.
Huh? 6?
Yeah.
Let's try 6. Drop down to 1. Oh, what drop down here? Which one?
The positive 40.
Oh, wait.
Mister.
Oh, yeah. Oh, yeah. I'm close. I'm testing you guys. You good.
I was
Negative
never,
48.
never
Found this. I just said, oh, I just said, if you make a mistake, it's called headache.
Let's go with your mind. So like,
See, that's a real example for you. If you make a mistake, it will come up synthetic. I just made it. So 0 is the remainder. This is the one. All right. So, if you know negative 4 is solution, what did you write? X.
well, why is it wrong?
If you know negative 4 is solution, what did you write? X plus 4. Yes, positive 4. X plus 4. How do I fill in this? Constant x squared. Very good. X squared minus 4x minus 12. All right. Now this is 3 terms and this is a square. This is the side that I'm going to use a combination, right? So what are 2 numbers multiplied to 12? 2 and 6, 4 and 3. Which one? Yeah, 12 and 1. Very good. Which one you think can give you 4? Which pair do you think can give you 4? 2 and 6, right? All right, 2 and 6. So 2 and 6. Now, what is the sign of 2 and the sign of 6 that can give you negative 4? Minus 6. Minus 6 and positive 2. Yes. Minus 6 and positive 2. So minus 6 and positive 2. That can give you negative 4. Yes. All right. So now what is solution? X is. Oh, so if we try the 6 as Shelly said, we try the 6, we also got the 6. If we didn't try this, we try the 6 also there. One of them is 6 also.
would have worked.
Yes, because it also solution right here. X is the negative 2.
So it could have been -2 too.
Yeah.
So it could have you could have tried all those numbers and it would have been this.
So if you go 1 by 1, oh, 1, -1, 2, -2, you will get the negative 2
We'll
on
always get
4
the
try.
same.
The same answer. You will get the same answer. Yeah, you get the same answer. Yeah? What do I missing? There's still one mistake, very critical mistake. I mentioned it in the beginning. This is a real testing and no one caught it.
Is it
The other one, I make a mistake for you.
Where's the mistake?
Now, yeah, for you to think, what is the mistake?
Give us a clue.
The X, yes, the X. Don't forget the X.
Oh.
Don't forget the X because why? X is also the solution. X equal to
0.
0. Don't forget the X, okay? You have 4 solutions right here. Here is also one more thing. Here's another trick. I put a note right here. The number of the solution is the degree. What is the degree right here?
4.
4. You would think you will have 4 solutions. You should think that. So if you only have 3 solutions like this, you're missing one. You're missing one. Unless they are double root or something. But if you only have 3 solutions, the degree is 4. The degree is 4 indicates that you're going to have 4 solutions. If the degree is 7, you're going to have 7 solutions. Unless you have like triple root, double root, or something else. here, when you stop right here, you see, oh, I only found 3 solutions, but the degree is 4. That's mean I'm missing 1. Now looking at back, oh yeah, I forgot this. That's how you check it. Yes, you right, right. You mean this one is the degree?
So we have to go to the original, we can't go to the.
Like this one? Oh, this one is all the same. You remember, we want to find a degree, we want to count the x times this.
That's higher.
I would say if you want to find a degree, you want to make it in standard form, easier to find. Yeah. But when you look at here, you can also say, oh, x times x3 is x4 is the highest one. Yeah. Any question? Yeah, good.
Let's make a break.
Yeah, last one.
I'm not writing this.
Last one and you're done. Last one and done.
These notes maybe been taking a blank.
Wait, mister, is this the type of math that you learn in Calc?
Huh?
Is this the type of like stuff that you learn in Calc?
Or is this algebra?
This is it's still algebra, but the one you're dealing with, the polynomial, this is calculus. Yeah. The polynomial is about calculus. Yeah. Calculus is about polynomial. This is the last one. This is the last one. This is the last one.
Oh my God.
Okay, look at this. Let's finish this. When you look at this, what are you gonna do? When you look at this, what are you gonna do? Huh? Group, yes. Watch out. Grouping. Boom.
Say it again.
Sao phân thì là 4,
Oh, that's cool.
1, 2, 3, 4. Yeah, here's the beginning. All right. This one, always try to do the order technique first. So this one turned out that you can do grouping. So you don't need to do this thing. So that's the last
There
sample.
will be 3 solutions.
Yeah. Right, good. Get your solution. So here, that's why I put it the last sample, because sometimes you don't need to always do the rational root theorem. Try the other method first. Okay. The order of the rational root theorem is defined, the last one. The rational root theorem is the last one you want to try. Okay. Try to do grouping. So this is grouping. Okay, let's do grouping. What is the GCF for the first two?
X. No, 3x.
3x squared. What do you have left? Minus
3, no, 2.
2.
We should do.
What is GCF for the last two?
3.
3 or negative 3? Negative 3. Very good. What do we have left? X? Negative 2. Yes. So the common factor is x minus 2. All right, so I took out the common factor x minus 2. What do we have left?
3x minus 3x squared.
3x squared minus 3.
You can take out 3.
You can take out a 3. Very good.
We can-
Oh, we actually can take out the GCF in the beginning. Yeah.
Oh, we could have done that.
Yeah, we could have done that. Take out GCF in the beginning.
3. Could have done 3.
Right. So now here, how can you break up this? These are two terms.
That's in my.
Wait.
Right.
Listen, you lost.
You have to say it out loud.
Put the 3 in the front. Okay.
Oh, I took out a 3 right here.
Fucking looking at you, thinking that you would notice.
You took out a 3 right here. Yeah, that's the GCF for this two. 3x squared and minus 3. So I can take out a 3. I put it outside. I can put it outside right here, but here same thing is here. Yeah.
Yeah, right there.
Okay. You normally put 3 right here, right? answer minus one, right? Remember multiplication, you can move around freely.
Oh, yeah, it doesn't matter.
And then this is always like, it's an unwritten rule that always put a number in the front. Like any parentheses on the back, because you don't miss this. So I move the 3 on the front. Yeah. And then this is two terms. What is the sign? What is the technique you're going to use for two terms? The formula.
What is it called?
Difference of square.
That's what it was. That was
What square become one? One plus minus one. Okay, so what is the solution for this? X is right. How many solutions do you have? 3. Power 3. So that's the 3 are from here.
What happens to it though?
Oh, no, nothing. Only when you have some x outside, that is going to be 0, but it's the number outside, it doesn't matter. Yeah, so that's conclude our lesson. This is the heaviest one. That's why, because we need to try and error. We need to guess. All right.